Hey students, Mr. Halpern here. So in the last video we were talking about what climate change was and is, and what are some of the causes, and what are some of the effects. So now that we're looking at the effects, we're moving on to increased droughts. So increased droughts causes overall decreased crop yields, which causes climate refugees. So when people don't have food, they have to move to new places, which causes inevitably geopolitical and national security issues like the Syrian refugee crisis. This is obviously not only about climate change, but it was certainly a factor that was influencing the move of so many people. The Syrian war was also a part of the effects of climate change. Next, the increased evaporation of water. So when temperature rises, the water turns to vapor more frequently, and this causes an increase in precipitation in different areas around the globe. As you can see around the equator, you have more precipitation, but you also have decreases as a result of the increases in other places. And so you see some places that also have droughts as well. Tropical pests, invasive species, and disease vectors tend to move to higher latitudes and higher elevations because temperatures are rising. And so you see the spread of things like, oh goodness, uh, uh, oh, I'm forgetting the names of some of the diseases that are particularly tropical, but they're starting to spread across the United States. Malaria will spread as a result because the vectors for them, mosquitoes, are spreading as well. Um, Birds are moving further north. Other mammals are also moving in higher altitudes, as we said. There are seasonal changes that are happening right now as a result. Plants are blooming a lot earlier. Pollinators are having to adjust to those bloomings being in different times. Therefore, breeding patterns, when organisms tend to breed in the spring, but spring happens earlier, they have to adjust their time frame. And then migration. Migration is connected to seasons and temperature as well. Increased forest fires also happen. As a result of the increase of droughts, you have more arid conditions in certain places that will cause more forest fires. As a result of the increase in precipitation, you have the increase overall of intense storms and extreme weather. And this is caused by the weakening of the polar jet stream. So this is a picture of the normal jet stream. And as it slows, it loops through, and you have more persistent weather patterns. So warm weather might move across the United States normally, but with a weakened jet stream, you have a more persistent hot weather event. More persistent weather patterns, as we said, like storms, heat waves, floods, tornadoes, hurricanes, snowstorms, and cold snaps. All of this has to do with the weakening of the jet stream. Okay, so those are the effects. How do we even study climate change? How do we prove through numbers and measurement that this is actually happening? There are two ways. One is by looking at something called radiative forcing, which is the amount of change in thermal energy that a particular factor causes. And we will look at the different factors that we really focus on, like carbon dioxide, ozone, methane, aerosols. We can see that there's a forcing of each one of these. And carbon dioxide is the biggest one, as you can see there. It's the biggest red bar. What that means is that it has the most impact on temperature. The amount of change in thermal energy that, oh, sorry, I've already said that. So, global warming potentials also are ways of us showing the importance and the impact of greenhouse gases. Carbon dioxide has a 1 in terms of its heat trapping potential or ability. Methane has 28 times that. Nitrous oxides has 265 times that of carbon dioxide. And CFCs have 12,400 times the impact. So why do we care about carbon dioxide then if all of these other ones are way better at absorbing heat, right? The answer is because we just have so much more carbon dioxide that we produce in the atmosphere than the other ones. Um, some detractors might say that the Milankovitch cycles are changing, and that's what's causing the temperature patterns that we're seeing. What the Milankovitch cycles are the long-term changes in the planet. So the planet tends to wobble a bit on its axis, and also varies its tilt. So instead of it being 23.5, it's a little bit less or a little bit more. Here's a, oops, sorry. There's a better picture of it down here. It can actually go down to 22 and up to 25 degrees. And then also there's slight variations in the orbit of the Earth around the sun. All of this has been studied, and still the impact of CO2 is still has been proven to be the number one factor in the increase in temperature. All of these different changes in the planet's normal cycles wouldn't account for the drastic change in temperature that we're seeing. The other way that we measure and study global climate change is through proxies, is by looking at the world around us and studying past trends or amounts and comparing it to current ones. For example, tree rings, ice cores and glaciers, pack rat middens, and coral reefs all give indications of how much CO2 is in the atmosphere all the way back to 800,000 years ago. And the way we do that is by looking at ancient bubbles of atmospheric gas. We can analyze that particular gas and compare it to current bubbles of gas. Certain places are obviously more impacted right now by global climate change. Islands, particularly like the Maldives, are examples of places that are really impacted because they have a very low elevation across the island typically. Also, places that are along coastlines like Miami, New York City, California, Texas, they have a lot of coastline, and so the big concern is sea level rise there. Reactions. How do we make change, right? How do we decide to address this? Well, there are two ways. One is through mitigation, and one is through adaptation. Adaptation is simply trying to adjust our world to global climate change. It's not addressing the root cause of climate change. It's simply saying that if sea levels are rising, we should build higher walls. Ways that we adapt, as we said, building higher walls, building higher roads. This is already happening. Restricting coastal development, increasing insurance costs so that families don't find it prohibitive to move to coastal areas, and adjusting farming practices to cope with things like drought or flooding. This is a picture of southern Florida, of Miami Beach, where they've had to raise the roads. And they predict that in about 10 years, they're going to have to do it again. Another way is through mitigation, where we actually try to decrease the amount of carbon dioxide and other greenhouse gases to, in effect, decrease the rate of temperature increase. What can we do as citizens? We can use less fertilizers or use more organic fertilizers rather than synthetic ones. Decrease meat consumption. Reduce the demand of fossil fuels. All right, changing the type of car that we might use that might have a higher mile per gallon. Substituting alternative technologies that release fewer greenhouse gases. So using solar panels versus using natural gas or oil, and changing out your light bulbs to LEDs. What cities can do, they can make it easier for citizens to get around by using bikes or having a car sharing program. Having more access to mass transportation is also really important too. Rezoning, if you're into urban planning, rezoning is a big way in which we can encourage citizens to travel locally or not have to travel long distances. And HOV lanes, high occupancy vehicle lanes, promoting the sharing of cars and the use of cars. Finally, governments and companies can do many different things. For example, cap and trade systems where governments set limits on overall emission levels, and then they issue permits to emit to companies, organizations, and utilities. And then they let the emitting parties buy and sell and trade these permits among themselves. But the idea is that we cap it, and so ultimately it will reduce the amount. Positives: the private sector can often achieve goals in an effective way with fewer costs. Negatives: if this might allow hotspots of pollution if they trade to trade off their permits. You might have one particular place that might be much higher in terms of the concentration. This is an image here that just shows you a bit about the cap and trade. As you can see, governments again cap the amount of emissions from all plants, and as a result of that, you can uh, cap and then trade your permits to other organizations, and there's an economic incentive. Another is by doing carbon offsetting, where one country pays another to reduce greenhouse gas emissions. It can be efficient and appealing, but will work only if there's a good amount of oversight internationally, and usually through the UN, and that um, we enforce regulation as well. Um, Having carbon taxes is another hot button issue right now. It was a big push in the Democratic parties and Democratic candidates to talk about carbon taxes as a way of reducing the amount of CO2, basically putting a tax on any activity that companies might do that releases CO2 in the atmosphere, and doing carbon capture and storage. A third way is through geoengineering. And there are many ways that are sort of big ideas that people have come up with, although they offer their own sets of issues too when we're doing big changes like this. And that's it for global climate change. If you have any questions, please let me know.